Everyone, in this video we will discuss one problem. The problem is like this: you are given two 32-bit numbers n and m, and we are also given 2-bit positions I and j. We need to write a function that sets all bits between I and j in n equal to m. So m will become a substring of n located at position I and static at j. So this is one example. So you can assume this is the binary of a given number n, right? So in the question you will be given an integer, but this is just for your visualization. So like this is given, so you have to place this m inside n, right? So between these two indices I and j. Okay, so I and j are computed from the right. So this is what you need to do. So finally you have to form this number. So now you cannot treat this as an array and you can keep on replacing bits. You actually have to use bitwise operators because the n and m are integers, not the strings, right? So let's discuss how we can solve this problem. Okay, so yeah. So let me show you what it is. So you are given n. Replace bits in m by m. So n is given like this: 1 0 0 0 0 0 0 0 0 0 0. This is what n is given. I is given as 2, j is given as 6, and we are given m as something like this. M is given as let's see, 1 0 1 0 1, and it is given we have to start from the second index. So 0 1 2 3 4 5 6, 1 2 3 4 5. We have to put these bits at these positions: 1 0 1 0 1. So your final number will become 1 0 0 1 0 1 0 1 0 0. Let's confirm. Yes, it is, right? So we have to make this number. So the very first step would be whatever the bits are there in the original n, right? We have to clear those bits. Okay, so first step is clear these bits. Okay, so for that we can use the clear bits in a range function that we have written earlier. We can use that function. Once the bits are cleared, then this problem becomes very easy, right? In that case you only need to do something like this, right? So let's say you have the number cleared n, which is, let's say, n dash, and this is given by the clear bits function. So you call clear bits, you give n, you give I and j. In that case you will get a number in which all bits are 0, and then you can do OR with m left shift I. So what you need to have in m is you want to do some addition like this: 1 0 0, you have the cleared region, you have 0 0 here, and m is given to you something like this: 1 0 1 0 1. So you need to left shift m by I places so that you will get two zeros here, and then you do the OR operation, the bitwise OR, and here you already have zeros in m, right? Once you do this, you will get the updated number. So this is how the bits of n are replaced by n. So whatever the bits were there, they were cleared. Okay, so how to clear bits is the main part, and that we have already discussed in one of the videos. So let's do OR and we are done, right? Okay, so now let's implement it in the form of code, and you can use this function clear range I to j. Okay, And now we can make this function int replace bits. You get n, you get m, you get I, you get j. So what you need to do is, first you need to get the value of n dash. So n dash is going to be equal to clear range I to j n I j. Next is you want to do compute your answer, that is n dash or with m left shift I, and you return answer. Now let us try to run our code on a simple example. Let's say n is 15 and let's say I is 1, j is 3, and let's say m is 2. Okay, let's see what it should be now. Yes, this should be int n dash. So we need to call cout replace bits n, m, I and j and l. So it shows answer is 5. So let us verify. So 15 is like this. So n is 15, 1, 1, 1, 1. I is 1. Okay. So this is 1, 2, 3. I said replace these bits with m is what? What is m? M is 2. Okay. So 2 means we want to put 0, 1, 0 here. Okay. So these bits become 0. So it becomes 0, 1, 0, 1, which is 5. So which means our answer is correct. And this is how we were able to solve this problem.